In the last class, we discussed about chemical bonding and we emphasized on electrovalent bonding. And we discussed precisely about how electron is being transferred from a metal to a non-metal. In this edition, 002 of chemical bonding, we are going to be talking about the other examples that we can see in formation of electrovalent bonding. We have formation of magnesium chloride, formation of aluminum oxide, formation of magnesium nitride, formation of magnesium nitride. Let's quickly discuss, then you on your own, you do this and send me your answer. Go to the comment section, go to this comment section, snap and update your structure for the formation of aluminum oxide. Let's quickly see. So what are we saying here? Magnesium plus chlorine to give us magnesium chloride. We all know that magnesium plus a chlorine molecule to give us magnesium chloride. Magnesium with electronic configuration 282 and chlorine with electronic configuration 287. Now, chlorine will be 2 atoms of chlorine will be reacting with 1 molecule of magnesium. So, or you say 1 molecule of chlorine reacting with 1 molecule of magnesium. Don't forget, atom plus atom gives you molecule. So a chlorine atom plus another chlorine atom gives you a what? A chlorine molecule. So which means 2 chlorine atoms reacting with a magnesium molecule here. So let's see what is going to happen. Now let's start. Don't forget our shell K, L, N. So we're going to be dealing with the M shell. So K, L, N. So let's start with the first chlorine atom. The first chlorine atom, which is having 287. So we are dealing with the shell N. The shell N. So 1, 2, 3, 4, 5, 6, 7. Plus the magnesium atom. Dealing with the shell M also 1 and 2. Plus, I believe we have this down. Plus another chlorine atom. 1, 2, 3, 4, 5, 6, and 7. So this is a chlorine atom. This is another chlorine atom. So what is going to be happening here is that this magnesium atom will be transferring this free electron to this place and will be transferring another one to this place in order to form a stable compound of magnesium chloride. Form a stable compound of magnesium chloride. So that after the combination, so this is the before combination. After combination, so that you can have a chlorine atom 1, 2, 3, 4, 5, 6, 7, and 8. Plus a magnesium for shell L. 1, 2, 3, 4, 5, 6, 7, 8. Having lost these 2 electrons in the outermost shell, then a chlorine also, which has benefit from the transfer of electron. So then we have a stable compound of magnesium chloride. a stable compound of magnesium chloride as a result of transfer of electron from magnesium to the chlorine. Transfer of electron from magnesium to chlorine. So on your own, you can do the formation of magnesium nitride and aluminum oxide. Go to the comment section, answer it, and let me see your result. The first 15 persons to submit that, we have a reward from Simplified channel. Let's move on. Let's talk about the other types of chemical combination we have. Let's talk about the covalent combination. Covalent bonding. Covalent bonding. Covalent bonding. Covalent bonding or combination. Covalent bonding or combination. Covalent bonding or combination. Covalent bonding or combination. This involves, so they ask us, what is covalent bonding? So we answer by telling them that covalent law is the bonding between two non-metals. Is the bonding between two non-metals. Is the bonding between two non-metals. It involves the sharing of electron between these two non-metals. In covalent bonding, there is no transfer of electron. In covalent bonding, there is no loss or gain of electron. What happened here is that the two non-metals come together to share what they have. To share what they have. There is no transfer of electron. There is no loss of electron. There is no gain of electron. Unlike electrovalent bonding. And this gives them their own characteristics. There is no formation of ion. Instead of formation of ion, there is formation of molecules. There is formation of molecules. Therefore, covalent compounds are non-conductors because there is no formation of charges. They are non-conductors. They are non-electrolytes. They are non-conductor. They are non-electrolytes. So let's see. We said covalent bonding is a bonding involving sharing of electrons between two non-metals, which leads to formation of molecules. It leads to formation of molecules. Let's quickly see example. Example: formation of water molecule. Formation of water molecule. So, water molecule. So, water molecule, let's see how it goes. Now, hydrogen atom plus hydrogen atom plus oxygen to give us two atoms of hydrogen, which is the molecule, plus oxygen. What do we have? An hydrogen with one electron at the outermost shell, plus another hydrogen with one electron at the outermost shell, plus an oxygen, 2, 6. Shell KL at the shell L having 6. 1, 2, 3, 4, 5, and 6 electron at the outermost shell. What do we have? Since they are going to be sharing of the electron, there is no transfer or gaining of electron. What we have here is the central atom, which is the oxygen, combining with one hydrogen, combining with the other hydrogen. Then we have the formation like 1, 2, 3, 4, 5, 6, 7, and 8. So for hydrogen, 1, 2, it has formed a stable structure. For oxygen, 1, 2, 3, 4, 5, 6, 7, 8. It has formed a stable structure. Then for oxygen, 1, for the other hydrogen, 1, 2. So this is what is involved. This is what is involved. There is no loss or gain. So this is your water molecule. So this is your water molecule. The aggregate of formation of water molecule. Aggregate of formation of molecule. This gives them their characteristics. So covalent bonding, as we discussed, can be divided into two. We have the ordinary covalent and the coordinate covalent. This is an example of an ordinary covalent. In coordinate covalent, which we are going to be talking about, it involves one of the atom sharing its own electron with the other one without bringing anyone. It involves in sharing the two electrons. Let's see in the formation of ammonium ion. Formation of ammonium ion. Formation of ammonium ion. Let's see the formation of ammonium ion. Formation of ammonium ion. Ammonia plus hydrogen ion to give you an ammonium ion. Literally, you know that when an element or an atom is carrying a positive charge, it's telling us that the element has lost electron. So ordinarily here, hydrogen here has lost its electron. So the representation of hydrogen here is 0. It's not having any electron at the outermost shell. While on the ammonia, nitrogen on its own has 5 electrons at the outermost shell. 5. 1, 2, 3, 4, 5. Because of its configuration, 2, 5. Then combining with 3 hydrogen, 1 hydrogen will come and bring its own electron. It forms a stable octet. Another hydrogen will come, bring its own electron. It forms its own stable duplet again. Then the 3rd hydrogen here will come. It's going to bring its own electron by sharing together covalently. Then nitrogen is having 2 spare electrons at the outermost shell. So ordinarily, as it is, ammonia has formed a stable compound by having 8 electrons already for nitrogen. 1, 2, 3, 4, 5, 6, 7, and 8, which makes an ammonia compound stable. Then all the hydrogen attached to it, they form a stable duplet. So the presence of these 2 electrons, it will not transfer. Then they will not share. They will not transfer. It will share with this empty hydrogen. It will share with this empty hydrogen, so that at the end of the result, you can have your nitrogen bonding with the 4 hydrogen and the charge here. So this is the kind of bond that exists. We said coordinate covalent is the type of covalent bonding that involves one providing the 2 electrons to be shared, while ordinarily involves the sharing of electrons between the 2 atoms. So I believe we understand these characteristics of these covalent compounds, and this gave them their special and unique characteristics. There is no formation of ion, it is only aggregate of molecules. Thank you for listening to the class. Thank you for staying tuned. Please don't forget to go to our page, share, like it, and subscribe. Thank you. See you some other time.